Hey Kevin, what are you doing?
I'm recreating the universe.
It all started with the Big Bang. The Big Bang created two kinds of particles. One we know as matter, which makes up everything that exists now, and antimatter, the opposite of matter.
After the Big Bang, there should have been an equal amount of matter and antimatter. But somehow, the balance shifted more in favor of matter. A collision of matter and antimatter annihilates each other, releasing 100% of energy. Just 1 kilogram of matter and 1 kilogram of antimatter is equal to 43 million tons of dynamite. Now everybody knows that the particles that make up matter are a negative electron, a positive proton, and a neutron. On the other hand, antimatter is made pretty much the opposite way. A positive electron, called a positron, a negative proton, called an antiproton, and an antineutron.
When matter and antimatter collide, it releases a gamma ray, or energy, with a wavelength of 511 keV. Now we know that antimatter exists because we have found traces of it in cosmic rays. Also, at the center of our galaxy, a black hole spews out antimatter particles, and scientists have been able to reproduce antimatter in a large hadron collider. Also, lightning has left traces of it. Let me sing to you about the Large Hadron Collider.
Oh yeah. I'm about to drop some particle physics in the club. The LHC is super duper fly. You know what I'm saying. Check it.
27 kilometers of tunnel underground, designed with mine to send protons around. A circle that crosses through Switzerland and France. 60 nations contribute to scientific advance. Two beams of protons swing round through the ring they ride, till in the hearts of the detectors they made to collide. And all that energy is packed in such a tiny bit of room, becomes a mass, particles created from the vacuum. And then...
Oh yeah.
LHCBCs are the antimatter gone. Alice is at collisions of lead ion. CMS and Alice are two of a kind. They're looking for whatever new particle they can find. The LHC accelerates the protons in the lead, and the things that are discovered will rock you in the head. We see asteroids and planets and stars galore. We know a black hole resides at each galaxy's core. But even all that matter cannot explain what holds all these stars together. Something else remains. The dark matter interacts only through gravity. And how do you catch a particle that there's no way to see? Take it back to the conservation of energy, and the particles appear clear as can be. You see particles flying in jets they spray, but you notice there ain't nothing going the other way. You say my law has just been violated, it don't make sense. There's gotta be another particle to make this balance. And it might be a dark matter, and for the first time we catch a glimpse of what must fill the known universe, because...
LHC sees where the antimatter's gone. Alice looks at the collisions of lead ions. CMS and Alice are two of a kind. They're looking for whatever new particles they can find. Antimatter is sort of like antimatter's evil twin, because except for charge and handedness of spin, they're the same for a particle and its intercell. But you can't store an outer particle on any shelf, because when it meets its normal twin, it will annihilate. Matter turns to energy and then it dissipates. When matter is created from the energy, which is exactly what they'll do in the LHC, you get matter and antimatter in equal parts, and they try to take back when the universe starts. The Big Bang, back when the matter all exploded, but then now the antimatter was somehow eroded. Because when we look around and we see that matter abounds, but antimatter is nowhere to be found. That's why...
LHCBCs are the antimatter gone. Alice looks at collisions of lead ion. CMS and Alice are two of a kind. They're looking for whatever new particles they can find. The LHC accelerates the protons in the lead, and the things that are discovered will rock you in the head. The Higgs boson, that's the one that everybody talks about, and it's the one sure thing that the machine will sort out. If the Higgs exists, they often see it right away, and if it does, doesn't, the scientists will finally say, there is no Higgs. We need new physics to account for why things have mass. Something our standard model weren't awry.
For the Higgs, I still haven't said just what it does. They suppose that particles have mass because this is this Higgs field that extends through all space, and some particles slow down while other particles race. Straight through like the particle has no mass, but something heavy on top of it is dragging it. And the Higgs is a boson that carries a force that makes the particles take orders from other fields and its source, so they'll detect it.
LHCBCs are the antimatter gone. Alice detect collisions of lead ions. CMS and Alice are two of a kind. They're looking for whatever new particles they can find. Not so long you may think that the gravity is strong, because when you fall off your bicycle it don't take long until you hit the earth and you say dang that hurt. But if you think that force is powerful, you're wrong.
You see, gravity is bigger than weak, and the reason why it's something many scientists seek. Think about dimensions, we just live in three, but maybe there are some others that we choose not to see. It's in two these dimensions that gravity extends, and make it seem weak here on our end. These dimensions are rolled up, curled so tight that they don't affect it in our day-to-day life. If you're as tiny as a graviton, you can enter these dimensions and go up and down, and they find you.
When LHCb sees where the antimatter is gone, Alice looks at the collision of lead ions. CMS and Atlas are two of a kind. They're looking for whatever new particles they can find. The LHC accelerates the protons and the lead, and the things that it discovers will rock in your head.
Oh yeah. Our understanding of the universe is about to change, thanks to the Large Hadron Collider. This is C to the E to the R to the N, coming straight out of Geneva.
Mr. B dropping the beats.
So Kevin, what do you think happened to all the antimatter?
I stole it. And I put it in this not yet invented theoretical method to hold and store unrealistic amounts of antimatter, as if it were sugar.
What happens if something goes wrong?
I don't know.
Nothing. You just die.